This presentation covers the topic of maintaining and operating a combined heat and power plant. Topics to be discussed are management personnel and operating engineers, maintenance of the prime mover, that is the gas turbine reciprocating engine, the maintenance that's involved in what we call the power block, the balance of plant maintenance, those things that are not part of the power block but comprise the entirety of the rest of the plant, the air permit reporting requirements, fuel contracts, maintenance of the distribution systems, and the advantages of third-party own, operate, maintain. Management personnel and operating engineers. Requirements for management personnel and operating engineers varies depending on the size of the plant, the steam pressure of the plant, and the complexity of the plant. Small plants or micro plants with low temperature hot water can sometimes run unattended. Small to mid-sized plants, those in the 1 to 5 megawatt range, generally require some sort of a manager or at least a part-time manager, a chief engineer, and 1 or 2 operating engineers per shift. Larger plants in the 5 to 25 megawatt range may require a director, or in some cases a manager, chief engineer, and 2 operating engineers per shift. New combined heat and power plants that are part of an existing heating plant may not require additional personnel, or perhaps only an incremental number of people. Prime mover maintenance. Generally, maintenance of the prime movers, the turbines or engines, are recommended to be carried out by the original equipment manufacturer. The maintenance contract for the prime mover should be negotiated and included as part of the maintenance contract. If this is not done at the time of the purchaser gives up some of his leverage in negotiating a good contract. Contracts should have the option to renew the maintenance at the original price indefinitely, but should include some type of escalation clause. Usually the escalation of the price is tied to an index, such as Consumer Price Index or the Metal to Metal Index, sometimes a combination of the two. Gas turbines specifically are rebuilt at certain time intervals. This runs in the around 3-year time period. The turbine has to be completely rebuilt. It's torn down and key elements of the turbine are replaced. Availability or uptime of the equipment should also be guaranteed as part of the purchase agreement, and that should carry a financial penalty to the original equipment manufacturer supplier as part of the contract. The scope of what's included is important. Some contracts and some manufacturers will only guarantee the prime mover and not the generator, or it may or may not include the lube oil coolers or other ancillary equipment that are part of the package furnished by the manufacturer. It's important because those additional pieces of equipment can fail and affect the availability, yet the manufacturer won't be responsible unless it's included in the contract. Lube oil coolers are one that has traditionally been a problem. Lube oil coolers that use air cooling can sometimes be ineffective in very hot weather and will cause the plant to shut down. In desperation, the operator of the plant then will spray water on the fins coolers, and that can cause damage. It's best to have the lube oil cooler performance guaranteed as part of the purchase agreement, and that will induce the manufacturer to engineer it correctly so that it will operate in hot weather. The guarantee of emissions is very important to be included in the contract. Without compliance for emissions levels, the plant can't operate. Maintenance of the fuel cells. Fuel cells are generally maintained also by the original equipment manufacturer. Routine maintenance by the operating personnel is somewhat less than for turbo or reciprocating equipment. However, when serious maintenance is required, such as restacking, which can occur in a 4 to 5 year or less time frame, it's a complete rebuilding of the fuel cell, and that can cost in the neighborhood of 60% of the original cost of the fuel cell. The balance of plant maintenance depends on if there was an existing plant prior to the installation of the combined heat and power plant. The most important piece of equipment for maintenance outside of the power block, and generally not supplied by the gas turbine manufacturer in the case of a gas turbine plant, is the gas compressor. The gas compressor is required to increase the fuel pressure of the natural gas that's injected into the gas turbine. Gas compressors are maintenance intensive and can sometimes be more troublesome than the gas turbines themselves. Heat recovery boilers are maintained much in the same way as a conventional boiler. The generator may or may not be covered under the maintenance contract, but it does require maintenance. Absorption chillers, not always included in a plant, but many times they are in cases where summer heat load is needed. Cooling towers, selective catalytic reduction equipment requires some maintenance, usually not often, but as the plant begins to age, they can require significant maintenance. Continuous emissions monitoring equipment is also something that has to be maintained. Typical equipment that's required are, again, pumps, switchgear. There's additional switchgear that's required as part of a combined heat and power plant. If the plant has black start capability, there's another generator set that must be maintained. If the plant has dual fuel, the fuel oil backup system, the storage tanks, the accounting system for the fuel has to be considered. Compressed air to operate instruments requires maintenance. The turbine lube oil coolers, as mentioned earlier, are something that has to be considered. And then the control systems for the power block itself and the balance of plant. Air permit reporting requirements. Larger plants or small to mid-sized plants can require a Title V permit. In a Title V permit, the reporting requirements every time the plant is started or stopped must be recorded. Every time one of the emissions levels is exceeded must be recorded in a permanent bound log. The fuel testing for natural gas is required, usually once or twice a year. It's not as frequent as the fuel testing for fuel oil, which is required on every load of fuel. Sometimes these loads can be combined in the shipments. If they're shipped at one time, they can be combined into a sample. But the requirement basically is for every load of fuel, the fuel oil must be tested. In order to firm up and shore up the economics for the combined heat and power plant, Usually some type of fuel contract is executed. This is in the form of a direct purchase contract, the term of which can be several years, depending on the length of time that's allowed. If it's a public institution, it may be limited to 3 or 5 years. Right now, with natural gas prices at historic lows, it's probably a good time to be long on natural gas purchase. A decision as to whether firm or interruptible service will be used. Interruptible service is generally at an advantaged rate, but it will require backup fuel, and then the backup fuel has the liability of storage tanks, piping, pumping, and environmental reporting. Long-term contracts can be tied to an index, usually future prices on the New York Mercantile Exchange, and a long-term contract should have some provision for the purchaser to get out of the contract or unwind the contract under certain conditions. Maintenance of the distribution systems for the thermal side include things such as repairing leaks. If it's an underground system and a leak is encountered, that requires an excavation, and it's costly and time-consuming, can interrupt service. Some thermal distribution systems may have expansion joints. Usually there's either an expansion loop or an expansion joint. Expansion joints require periodic maintenance. In order to protect underground steam or hot water distribution systems, cathodic protection is provided. The cathodic protection system is not always passive. It requires some intervention in order to keep it maintained. Many of the steam or hot water distribution piping systems have an outer casing and an inner piping area that's insulated with an annular airspace between the two. That airspace should be periodically ventilated in order to keep the insulation dry. Manholes require maintenance. They may need pumps inside them, lights inside them. There may be leaks inside them. In order to enter that space, confined space, equipment, and training is required. Electrical distribution system maintenance. Electrical distribution system maintenance requires periodic inspection of splices and termination points. That can be accomplished many times using infrared cameras. Switches must be maintained and calibrated. Testing for the integrity of the cabling can be accomplished using low potential DC testing rather than a high pot alternating test. This will not stress the cabling, and yet it will identify any leakage of current to ground. Transformers require maintenance. The oil inside the transformer has to periodically be tested for moisture. The outside should be inspected and the terminal points cleaned and inspected. The advantages of third-party own-operate. There are many advantages of third-party own-operate. One is they have specialized knowledge and experience. There may be tax advantages if the combined heat and power plant is for a nonprofit or governmental owner. They are not able to take advantage of the tax credits and other tax considerations, whereas a third party would, and that helps to buy down the cost of the plant. One of the main advantages of having third party own, operate, maintain is that the facility can concentrate on their core mission rather than become involved in the operation and maintenance of the plant. A portion of the financial risk is also transferred to the third party. Now, this may or may not be off-balance sheet financing, but it can still have some impact on the facility's ability to bond or borrow. The disadvantages of third-party own-operate. The principal disadvantage of having a third-party own-operate is that savings have to be shared, and therefore there's less savings to be realized. There's also the possibility of contractual disputes, which can be troublesome and time-consuming. And there can be a conflict of goals. The third party may be more concerned with shareholder return on investment as opposed to the building occupant's satisfaction. Thank you very much, and if you have any additional questions, please do not hesitate to email me at pmeerd.source@gmail.com.